Considering OPcache preloading to get even more performance out of your PHP application? There are only a few special cases where preloading will have a measurable impact on your application performance. And in this video, we are going to cover what preloading is, how you can set it up, and configure it in your application, and what performance gain you can expect. Moin, I'm Benjamin and living and breathing PHP performance for the last 10 years now, helping thousands of developers, companies and open source projects to speed up their PHP code. Preloading is a core PHP feature since version 7.4 and was contributed by Dimitri of Zend back in 2018 and was accepted unanimously during voting. This feature allows you to preload scripts at the startup of the PHP process when no requests have run yet. Then each request run in the process has these preloaded functions and classes already available immediately as if they were internal classes. This is different than OPcache itself, which improves and eliminates the time spent compiling PHP scripts to bytecode through caching. Preloading complements OPcache by reducing time spent in the autoloader that may also take up a significant portion of your request time. So on paper, preloading should eliminate the time spent autoloading classes and reduce the response times in that share. The downside of preloading is that every startup of PHP FPM or Apache 2 is taking a longer time because the preloading script has to be compiled and run and put into memory. To use preloading, there are three prerequisites. First, your application has to be the only one running on the server. This is usually the case in modern PHP deployments, but I want to mention it regardless. Second, you must be using PHP with either PHP FPM or Apache 2 with mod PHP or any other SAPI that is shared nothing architecture based. Preloading has no effect on application servers such as FrankenPHP, Roadrunner or Laravel's Octane. And in runtimes such as Brev on AWS Lambda, it may shift performance around only from the request to the boot time, but in a way that users will still feel and recognize. The third requirement is that you write your own preloading PHP script. That script must essentially require all the files that you want to pre-compile and preload into the PHP process. The Symfony framework generates this by default. Laravel has, for example, a third-party package that allows to do that, which I haven't tested myself. In other cases, and when you don't use those two, you have to write this yourself or find packages that do this for your framework. The PHP documentation has information on how to do this in your application. In the preloading script, any file referenced by include once and so on, OPcache compile file, will be parsed into persistent memory. In the following example, all PHP files in the source directory will be preloaded unless they are a test file. So we can see here a script iterating the source directory, excluding test files, and then require ones on the file. This does not take into account that scripts might have dependencies on each other with either inheritance or types used for arguments and return types. So this has to be taken into account and the order has to be the correct one to include. Because we don't have autoloading in place here, you essentially have to do the mapping yourself, which file comes first and which one comes after that. And then you include them like in the right order. Then you have to configure the PHP INI with two settings. OPcache preload points to the file that we've created before or our framework created, and OPcache preload _user is the Linux user that the process switches into when running the scripts. After the change, just restart PHP FPM or Apache 2 and then monitor your error log files or your exception tracking software such as Tideways to make sure that everything runs smoothly. That's it. To see if OPcache preloading is working, you can call OPcache getStatus, the function, in your code and look at the newly added preload statistics key that is only available when preloading is enabled. It includes a metric called memory consumption to understand how much memory the preloading stage used. And I haven't looked at the PHP source code, but I would expect this memory to be taken from the regular OPcache memory buffer and counting toward this limit. In all honesty, I have not gotten around to test preloading on Tideways before, but it's hovering in my to-do list since it came out. This week it was finally time to evaluate. The reason for not looking into it for the last 5 years is that I didn't expect the performance benefit to be large enough that it mattered looking into it and getting familiar with this feature. So let's look at a demo application and how much time it spends in autoloading and compiling. We can measure this with Tideways, which is hooking into 2 PHP engine level hooks available to PHP extensions. The first one is called ZenCompile, which is related to compiling PHP scripts, and the second hook is called ZenAutoload, which is related to, you would guess, autoloading. By overwriting and adding timing to both hooks in our Tideways PHP extension, we can see how much time an application spends in both layers. At this time, there's no way to measure this in userland PHP code unless you directly patch the autoloader using high-resolution timer calls. Let's take a look at the Shopware demo application, which is written in Symfony to see what impact we can expect from autoloading in PHP scripts. So in the history module, we can see the performance of layers over a large amount of time, in this case 5 weeks. And we can see autoloading here is around 10 to 16 milliseconds on average in every request. And this is across all these thousands of requests that were made during that time. And if we set this in relation to the 95th percentile of performance of the complete scripts, then we can see with them being around 1 second, the autoloading performance is actually below 1% share of the whole PHP request time. And preloading only improves the autoloading time, so we don't expect this to be anything that improves visibly for users or makes the performance better in any significant way. But what if your application is already fast and takes less than 100 milliseconds to load? Let's take a look at the impact that preloading has on the Tideways backend. Because Tideways is based on Symfony and Symfony already generates a preloading script through the dependency injection container, my colleague Tobias and I could test the impact of preloading with just 2 hours of time investment. First, we started with an assessment of the potential impact that this preloading change could have on the performance of our data ingest service. The data ingest service has a response time of around 19 milliseconds in the 95th percentile, and the average is lower at around 12 milliseconds. We can see in the history of Tideways that in the last 5 weeks, the performance that autoloading had, the impact that autoloading had on this performance was always just 1 millisecond. So if we set this in relation, we are expecting to see a 5 to 10% improvement by using OPcache preloading. We rolled out this configuration change to our application servers and used Tideways to create a marker that allows us to compare the performance before and after this configuration change. We can see on this marker for the service, for the data ingestion service, that the performance improved by 10%, going from 20 milliseconds to 18 milliseconds in the 95th percentile. So exactly what we thought was possible before. And the requests here we can see at 32,000 per minute. We can also see this by hovering over the layer performance graph here, where we can see that before the change, autoloading is still responsible for 2 milliseconds of the performance, and afterwards it's not responsible for the performance anymore. We can also see this effect in the marker that we've added to the API service. The API service only has 4,000 requests every minute, so it's used a little less, and the performance dropped from 34 milliseconds to 32 milliseconds, still an improvement of around 5%, and that is very good for these kind of very fast requests. We have also tested this in our staging environment, where you can see that before the configuration change, autoloading took about 7 or 8 milliseconds on average, and after the change it's not visible anymore, and the performance dropped from 40 milliseconds to 30 milliseconds for a 25% improvement in performance. However, think that this is just our staging environment, and it's limited in resources and also doesn't have a lot of requests. As you can see here, just 6 requests every minute. So this improvement is not really showing real-world potential. While preloading does not improve performance in a way that users feel, it allows to handle more requests and increases throughput capacity for high-traffic applications. Consequently, you should look into OPcache preloading if your application is already very fast and has response times of below 100 milliseconds. This might allow you to save costs by reducing aggregated CPU count. With higher response times, I don't think preloading is actually worth it. But maybe there are other OPcache settings that you haven't optimized yet. See this next video for details, and don't forget to subscribe to the channel or our newsletter on PHP performance topics. See you around!